Now for the question part, the question number 1 asking about how the surface morphology of the sample. The surface morphology of the ceramic has higher porosity than glass ceramic and alloy. This makes ceramic the least stronger. The second highest porosity is glass ceramic followed by alloy. Glass ceramic is stronger than ceramic but not as strong as alloy. Alloy is the strongest with lower porosity. The question number 2 asking if the particle size distribution can be observed using optical microscope. Yes, it can be observed using this microscope. This is because the optical microscope is applicable to the particles in the size range of 0.8 until 150 micrometers and down to 0.001 micrometer using electron microscope.
The microstructure of ceramic is made up of microscopic crystals called grains. The smaller the grain size, the stronger and denser the ceramic materials is in general. When it comes to glass, the microstructure is non-crystalline. When these two materials are joined to form glass ceramics, the glassy phase frequently surrounds tiny crystals, forming a link between them. Ceramic materials are mainly composed of crystalline grains with a small amount of glass phase at grain boundaries. Glass ceramics are a special group of materials consisting of at least one crystalline phase and glass symmetric. Crystalline phases are embedded into glass matrix. The crystallinity varies most frequently between 30% and 70%. Two types of interfaces can be found in glass ceramics. One is the interface between crystalline phases and the other one is the interface between the crystalline phase and the glassy matrix. Aluminum copper alloys are usually complex because of the many additives used for the strength, corrosion resistance, or grain structure control. Alloy T24 with aluminum, copper, magnesium, manganese, iron, and silicon altogether has a multi-phase ingot structure. The higher dysprosium concentration and pronounced bending inherited from the cast structure may result in highly elongated recrystallized grains.
For the conclusions of these experiments, give an important information about the structural of materials. It also determines the structural of parameter meet particular requirements. There is also a lot of information regarding the microstructure's characteristics and configurations. Apart from that, findings of the experiments are quite beneficial in evaluating the materials. The microstructure study provides very essential information about type of solid materials, which are alloy, glass, ceramics, and ceramics. Microstructure inspections, which is employed in industry, is used to identify materials failures.
Next, for the question part, question number 1 asking two methods that can determine the density of solid materials and the difference between the two methods. The first method is gravimetric buoyance method. By comparing an irregular shaped object's mass in air and its effective mass when submerged in water, this technique may be used to determine its volume and density. The second method is gravimetric displacement method. This method to find volume requires submerging the object in a known volume of water and measuring the change in water level. Question 2 asking about why the density important in material science. Density is important in material science because one of the object's most essential and easily measured physical attributes is its density. Densities are commonly used to identify pure substance as well as to describe and estimate the composition of a broad variety of mix.
The density of each material is different because of their mass of atoms, their size, and how they are arranged determine the density of the materials. The more mass of an object has in a particular amount of space, the denser it is. It is vital to understand that this relationship is not only about how closely atoms of an element or molecules of a complex are packed together. The atomic mass of an element or compound has an impact on density. This is because atoms make up materials. Some atoms are heavier than others, which is that they have more protons and neutrons, and there are a lot of them despite their small size. It also relies on the way they are set up. There are more of them in a given space if they are packed closer together. The quantity of atoms in a particular space is what density is. Other than that, the mass of materials in air is different than in water, which is that the mass of materials seems lighter in the water compared to the air. It is because in air there is a buoyant force equal to the mass of air displaced by the object, as well as an equal and opposing force of the item's weight if the object is on a horizontal surface. And in water, there is also a buoyant force equal to the mass of the water displaced by the item pressing up on the object, as well as a normal force if the object is resting on a horizontal surface, it is according to the Archimedes principle. However, because air is less dense than water, its buoyant force is less, making an item in air appear heavier.
In conclusion, for this experiment proved that to determine the density of solid materials, it can be measured by using metal Toledo density kit SS64. One of an object's most essential and easily measured physical attributes is its density. Density are commonly used to identify poor substance as well as to describe and estimate the compositions of a broad variety of mixes. The findings of this experiment also shows it is good using Archimedes principle to measuring density even there are some error after collecting the data.